Question 1. X plus 1 is increased by 20%. Its value is now the same as x plus 4. Work out the value of x. Okay, so guys, this is, as you know, non-calculator. So we're going to do x plus 1. We're going to increase it by 20%. So that's the same as multiplying by 1.2. So it's something increased by 20, multiplied by 1.2, and we get x plus 6. So that's the key to the question, guys. Now we've got an equation. We hopefully can solve this. So let's multiply out. So I have, you could actually make this guy's 6 over 5 if you preferred. I'd actually do that, but I think most people would prefer to leave it as a decimal. So let's just multiply it out. 1.2x plus 1.2 equals x plus 6. Subtract the x over here, 1.2x minus x, and subtract the 1.2 here, so 6 minus 1.2. That means 0.2x, 1.2 minus 1 if you like, is 0.2, equals 6 minus 1.2 is going to be 4.8. So x is 4.8 over 0.2. If you want, guys, you can multiply above and below by 10, and you get 48 over 2. What's 48 over 2 but 24? So answer 24. Question 2. The point, minus 6 minus 4, lies on a straight line with this gradient. Work out the coordinates of the point where the line crosses the y-axis. Okay, so first, let's just get our equation of the line. I personally like this formula, guys. Y minus y1 equals m into x minus x1. We have m, and we have x1 and y1. This is our m. So I can say y minus y1 is minus 4. So y minus negative 4 equals m 3 over 2 into x minus negative 6. This is, of course, they've not given us a whole lot of space, guys, but it's y plus 4 equals 3 over 2 into x plus 6. So that's the equation of the line. It crosses the y-axis, when x equals 0. Y-axis when x is 0. Therefore, we have y plus 4 equals 3 over 2. This is 0, so it's 3 over 2 into 0 plus 6, if you like. 0 plus 6. Y plus 4 equals 3 over 2 times 6, which is 18 over 2, which is 9. And then y is equal to 9 minus 4, which is 5. So the coordinates are x is 0 and y is 5. Question 3. We have f of x, piecewise function, is equal to these 3 pieces, if you like. On the grid, draw the graph of y equals f of x. So firstly, from 0 to 1, we're going to do 4 minus x. This is a straight line that crosses through the y-axis. This is like y equals minus x plus 4, if you like. So the x-intercept is 4, and the gradient is negative 1. So it's just going straight down like that until 1. If you want to sub in 1 in here, you'll get 3. So that gives you the second point. So down to there. Then we have a quadratic here. So 4x minus x squared from 1 to 4. For this one here, guys, let's just do y equals 4x minus x squared. So I'm actually going to do the different x values here. You can even make a table. So let's do x and y like this. And I'm going to put in, so we're going from 1 to 4. So I'll put 1, 2, 3, 4. So when x is 1, we have 4 times 1 minus 1 squared, which is just 4 minus 1, which is 3. When x is 2, we have 4 times 2 is 8. 8 minus 2 squared is 8 minus 4, which is 4. Obviously, guys, take your time doing this. This will be, when x is 3, 12 minus 9, which is 3. And then here we have 16 minus 16, which is actually 0. So let's just put in those points. 1, 3 is here. 2, 4 is here. 3, 3 is here. And 4, 0 is here. So it's just a quadratic. That's actually going to be the maximum there, guys. So it's going to go up like that, down like this. Maybe try and draw it better than what I just did there, guys. Let's just try that again. Down, through that, and, well, that's just not good enough, guys. Okay, something like that. Okay, and then finally, for y equals 2x minus 8 from 4 to 6. Again, you can do a table, guys. X and y. Table from 4 to 6. So we'll go 4, 5, 6. When x is 4, y is 0. 4 times 2 minus 8. When x is 5, it's 10 minus 8, which is 2. When x is 6, it's 12 minus 8, which is 4. So 4, 0, 5, 2, and 6, 4, which is just a straight line through these points, like that. And we're done. Okay, 3b. G of x is 6 minus 3x. Work out g minus 1 of x. Okay, so firstly, guys, let y equal 6 minus 3x. Swap x and y. So x equals 6 minus 3y. Then rearrange. I'll add, let's just do it over here. I'll add the 3y here, and I'll subtract the x over to the other side. So it's 6 minus x. And then I just have to divide by, I will just divide by 3. So y is 6 minus x over 3. And then you have to write, guys, make sure you write g minus 1 of x equals 6 minus x over 3. Okay. Question 4. Circle the value of tan squared 30. Okay, we need to know, guys, tan of 30. So tan of 30 is, let me do that in my head, it's 1 over root 3. So this is 1 over root 3. So tan squared 30 is going to be 1 squared over root 3 squared, which is 1 over 3. So it's this guy here. On the axis, sketch the graph of y equals cos x. Okay, definitely we need to be able to do this, guys. It goes when x is 0, y is 1. It goes through 90 and 0, 180 and minus 1, 270 and 0, and 360 and 1. So it just looks something like this, guys. Please draw it better than me. I struggle with this tablet. Okay, there we go. That is 4b. 5a. Work out the values of a and b. Okay, so the left side is equivalent to the right side, which means I can equate coefficients. So let's just multiply this out here. First, the left-hand side. 3x times 5x is 15x squared. Then 3x times minus 4 is minus 12x. A times 5x is plus 5ax. And then a times minus 4 is minus 4a. This is equivalent to 15x squared minus 2x plus b. So the way this works, because they're equivalent, the 15 must equal to 15. That's the coefficient of x squared. Obviously 15 is 15. The minus 12 plus 5a, the coefficients of x, must equal minus 2. And the constants, let's say minus 4a, must equal b. So let's just go to the green one first, guys. Minus 12 plus 5a equals minus 2. 5a equals minus 2 plus 12, which is 10. So a equals 2. And then the yellow one, minus 4a equals b. We know a is 2, so minus 4 times 2 equals b. b equals negative 8. Okay, done. Question 6. Work out dy dx. Okay, first thing to do, guys, is multiply this out. So I'm going to multiply this out. This times this is 2x to the 7, 4 plus 3. Then plus this times this will give me 4x to the 4. And then this times this will give me minus. 2 times 3 is 6. And then x to the 4 over x will give me x cubed. dy dx is then equal to 7 times 2 is 14. 14x to the 6 plus 4 times 4 is 16 x cubed. Subtract 1 from the power. And then 3 times 6 is 18 x squared. Subtract 1 from the power. There we go, and you can write it there if you want. Question 7. ABC is a right angle triangle with vertices A, B, and C. Given, work out the length of BC. Okay, I guess we could, guys, we don't even need A. We could just use the length of a line formula here. But I assume since he's given us A, B, and C, he probably wants us to draw something. So, or at least see where this triangle is. It's probably, and the fact that it's right angled, he probably wants us to use Pythagoras or something. So let's have a look. So minus 1, 5, let's say is here. Let's say that's A. That's minus 1, 5. Minus 2, 5 would then be here. And then minus 1, 5 and 3/4 would be like, okay, here. And he wants us, this is our A, B, C. Okay, so fine. Our length here, B to A, that length there is literally just 1, because this is like minus 1 and this is minus 2, so that length is 1. And similarly here, A to C, they're both with an x coordinate of negative 1. This is 5 and this is 5 and 3/4, so that length is just 3/4. So this length, let's just call it x. So now we can say x squared equals 1 squared plus 3/4 squared. X squared is equal to 1 plus, this is 9 over 16. 1 plus 9 over 16, which is equal to, well, that's, guys, 16 over 16 plus 9 over 16, which is a nice number, guys, 25 over 16. Once you have 25 over 16, you can say x is the square root of 25 over 16. Square root of 25 is 5. Square root of 16 is 4. So we get a nice 5 over 4. It would have worked, guys, if you did it the other way, but I guess that way was a bit neater. Okay, question 8. Use matrix multiplication to show that in the xy plane, a rotation of 90 degrees anti-clockwise about the origin followed by a reflection in the line y equals x is equivalent to a reflection in the x-axis. Okay, so let's do the 3 of these separately. So the first one, let's say rotation, well, let's just call it rotation, guys. So let me go to the, if we remember, guys, our identity matrix. Our identity matrix is our 1, 0, 0, 1 points. So this is 1, 0, 0, 1 here. This is 1, 0. This is 0, 1. Let's just write it 1, 0, 0, 1. And that corresponds to this matrix 1, 0, 0, 1. Now the rotation 90 degrees anti-clockwise would basically put, we're going anti-clockwise, that is, well, the clock goes that way, guys, so anti-clockwise is this way. So the 1, 0 goes to 0, 1, 0, 1, and the 0, 1 goes to negative 1, 0. So we're rotating these two over here so that this goes to 0, 1 and this goes to negative 1, 0. So that's the rotation. The reflection in the line y equals x, let's write it here. Reflection, Okay, that is in this line here, guys. This is the line y equals x. The reflection will be the 1, 0 again actually goes to here. So the 1, 0 goes to 0, 1 because he's just going straight across, being reflected straight across to there. But then this one gets reflected to here. So the 0, 1 is now going to 1, 0. So this is the reflection. This guy gets over there. And then finally, let's do okay, so this is the reflection in y equals x. And then let's do reflection, this is the third one, reflection in x-axis. Okay, the reflection in the x-axis, this guy, because he's on the the x-axis, when you reflect it in the x-axis, he's just going to stay the same. So that's just 1, 0. And then this guy, when you reflect it in the x-axis, he's going to go down here to 0, minus 1. Okay, so those are the three transformation matrices. We want to use matrix multiplication to show that this followed by this gives you this. So it's nice to actually write down what you're trying to do, guys. So let's do here we want the rotation followed by reflection in y equals x. That is going to be this one. The rotation is 0. The rotation is 0, 1, minus 1, 0. And then if I'm doing this transformation followed by this one actually goes first over here. It's a bit like a composite function when and it is a composite transformation. So we do this one first and then this one after, hence it goes before it. Now, that's obviously a little bit complicated, guys, but that's how it works. Anyway, when I multiply this out, I should get this if I've done this correctly. So I do 0 times 0. This times, remember, I do row times column. So I do this row times this column. So it's 0 times 0 plus 1 times 1. Then I do this row times this column, top right, if you like. 0 times minus 1 is minus 1. 1 times 0 is 0. Bottom left, 1 times 0 is 0, and 0 times 1 is 0. And then bottom right, 1 times minus 1 is 1 times minus 1 is sorry guys, I just realized I've done something wrong. This guy's wrong. So top right, 0 times minus 1 is 0. 1 times 0 is 0. So 0 plus 0. This one was right, 0, 0. And then this one, 1 times minus 1 is minus 1. And 0 times 0 is 0. So this is actually going to give me, guys, this is going to give me 1, 0, 0, minus 1, which is the same as reflection in x-axis. Okay, if you know your matrix transformations, guys, that's not a bad question. They're all pretty similar. Just make sure you know how each of them works related to this. Okay, question 9. A quadratic sequence is this. Work out an expression for the nth term. Okay, so guys, the way I do these is this. I go minus 2, minus 1, 4, 13. So the first difference is 1, then 5, then 8. Add 1, add 5, add 8. And then the second difference is 4 and 4. Now if it's quadratic, these will be the same. Then we go 2a equals 4. So a is equal to 2. Now, why we have these rules, guys, I'm not going to get into in this video, but it's quite straightforward. So a is 2. The next rule I have is 3a plus b must equal this one here. So, sorry, 2a is this, 3a plus b is this, so 3a plus b is equal to 1. We now know a is 2, so this is 6a plus, sorry, 6a. A is 2, so 3 times 2 is 6, plus b equals 1, so b is equal to -5. And then finally, this one, this guy, is equal to a plus b plus c. So a plus b plus c is equal to -2. I have a, it's 2. I have b, it's -5. I don't have c. Let's just do this. Then I'm going to subtract the 2, so that's -4. Add the 5, that's going to be 1. C is equal to 1. So now I have a, b, and c, and it all comes from, guys, it all comes from a(n) squared plus b(n) plus c. So my answer is a, which is 2, 2n squared, plus bn, b is -5, so it's -5n, plus c is 1, and that's the answer. 9b. A different quadratic sequence has nth term this. Use an algebraic method to work out how many terms in the sequence are less than 2000. Do not use trial and improvement. You must show you're working. Okay, so no trial and improvement, guys. I'm going to say n squared plus 10n, this is 3 marks, has to be less than 2000. Okay, then we go, this is a quadratic inequality, guys, so I'll go n squared, n squared plus 10n has to be less, no, sorry, minus 2000 has to be less than 0. Okay, then I have to factorize it, so I need factors of 2000. Now, this is obviously slightly tricky, but it's factors of 2000 that add to give you 10. So immediately I'm thinking 210, which is no good. Then I'll think 20 and 100. That is also no good. If you want to think of it, guys, as factors of 20 that add to 1, that actually makes it easier. But it's going to be 40 and 50, and it's going to be plus 50, and it's going to be plus 50, and it is going to be minus 40. Okay, this has to be less than 0. Now, the way we do this, guys, to solve the inequality is we graph it. So I'm going to graph over here, very quick sketch of this quadratic with factors at -50, -50, and 40. -50 and 40. Why is it -50? Well, because if where it equals 0, so I'll just say consider, guys, consider n plus 50 times n minus 40 equals 0, then n equals -50 or n equals 40. Now this is not the answer, this is just so I can sketch it. So I sketch this. Now, where is this less than 0? Less than 0 along here. So n has to be, like, again, guys, I have no space, but let's just write it here. N has to be bigger than -50 and less than 40. Now, we're trying to find the number of terms. The number, or how many terms in the sequence are less than 2000. So I obviously want the largest, n here. So the largest n that is less than 40 is 39. So how many terms? Answer 39. Okay, question 10. Rationalize and simplify fully. Okay, root 3 plus root 3. We're going to multiply above and below, guys, by the conjugate of the denominator, which is 3 minus root 3. Okay, this times this gives you 3 root 3. Root 3 times root 3 is 3, so it's minus 3. And in the denominator, 3 times 3 is 9. 3 times minus root 3 is minus 3 root 3. Then plus 3 root 3. And then root 3 times minus root 3 is minus 3. This equals 3 root 3 minus 3 over, these cancel, which I expected. This is why we multiply by the conjugate. And then 9 minus 3 is 6. Divide by 3, and I get root 3 minus 1 over 2. Okay, question 11. Expand and simplify fully. Okay, binomial expansion, guys. I am going to use Pascal's triangle. So let's do that here. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, then guys, I go 1 bracket, bracket, plus, it's this one that I'm doing, guys, plus 5 bracket, bracket, plus 10 bracket, bracket, plus 10 bracket, bracket, plus, I'll skip a line here, guys, 5 bracket, bracket, plus 1 bracket, bracket. Okay, this is all the same expansion here. The first bracket, we have to put 3, the first term here. So it's 3, 3, 3, 3, 3, 3. The second bracket, 2x, 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 2x. The first guy, we go 5, 4, 3, 2, 1, 0. And the second one, we go 0, 1, 2, 3, 4, 5. Okay, then we'll do it term by term. This one is just 3 to the power of 5. 3 to the power of 5, guys. Are you supposed to know that? Well, 3 to the power of 4 is 81. 3 times 3 times 3 times 3. You can do that. 3 to the power of 4 is 81. And then if you really want to do 81 times 3 like this, you can go, it's 243. So the first term is 243. Then the next term, okay, this is getting kind of tricky. We've 81. Okay, well, it's 10, so that's actually quite nice. 5 times 2 is 10. 3 to the 4 is 81. 81 times 10 is 810. So this is 810x. Okay. Then 3 cubed is 27. 2 squared, just be careful, so I have to do 2 squared is 4, and 3 cubed is 27. So it's 4 times 27. Might actually just do this up here, guys. 4 times 27, 28. 4 times 2 is 8, plus that is 108. Okay, fine. So it's that's 108 times 10. So it's actually 1080. And don't forget it's x squared. Okay, then, I appreciate, guys, this is kind of annoying. Okay, we've 2 cubed is 8. 8 times 3 squared is 9. 8 times 9 is 72. 72 times 10 is 720. And it's x cubed plus, nearly there. Just note, guys, the 5 times, oh no, it's not 2. It's going to be 16. So it's 16, and then times 3 times 5. So I'm going to do 16 times 3 is 48. 48 times 5, 48 times 5. I would actually, guys, just do 48 times 10 is 480 divided by 2 is 240. So it's 240 x to the 4. You can obviously just do this as 0 remainder 4. Then 20 plus 4 is 24. And then finally, thankfully, this one's easy. Well, somewhat easy. This is going to be plus, let's do it here, 32. 2 to the power of 5 is 32. And then it's x to the power of 5. Let me just move this whole thing over here. Well, whatever. Okay, and that's it, guys. That is the full expansion. Question 12. The nth term of a sequence is this. One term of the sequence is that. Work out the value of n. Okay, so that's not too bad, guys. I can just equate. So it's 3n squared over n squared plus 2 equals 32 over 11. Okay, cross multiply. 11 times 3 is 33. 33n squared equals 32n squared plus 64. Okay, and then it's quite easy, guys. I can just subtract this over here. 33 minus 32 is 1, so just n squared equals 64, and then n is equal to 8. N is the term of a sequence, guys, so it definitely has to be positive, so it's 8. Then he says, write down the limiting value of the sequence as n approaches infinity. Okay, so it's simply, guys, just 3 over 1, which is 3. So the answer is 3. Why is that? Well, as n gets big, imagine x was like a million, you get 3 million squared over 1 million squared plus 2. The 2 basically becomes irrelevant, and you just have kind of like 3 trillion over 1 trillion, which is 3. Okay, that's 12. Question 13. Simplify fully this. Okay, so we have 6x cubed y minus 2 plus 9x to the 5y, and I'm just going to put this all over this because it's the whole thing divided by this. So it's 3x squared y minus 3. Okay, so we'll just do them separately, guys. We'll do this one here. So I do 6 divided by 3 is 2. X cubed divided by x squared is x. And y to the minus 2 divided by this. So we subtract the power. So it's minus 2 minus negative 3, which is actually minus 2 plus 3, which is just going to be 1. So we get 2xy like that. And this one, we do 9 divided by 3 is 3. X to the 5 over x squared is x cubed. And then y, again, like y to the 1 minus negative 3 is plus. So it's going to be 1 plus 3, which is 4. So that's going to be y to the power 4. And that's it. Question 14. Rearrange EF equals this to make E the subject. Okay, so first, guys, cross multiply, giving me 3EF equals 5E plus 4. Then I'll subtract 5E, so 3EF minus 5E equals 4. And this is the trick. I have to factorize out the E. So I'll have E into 3F minus 5 equals 4. E is equal to 4 divided by 3F minus 5. And we're done. Okay. Question 15. B, C, and D are points in a circle. A, B, and A, C are tangents to the circle. Prove that y equals 90 plus x over 2. Okay, now when we're proving it, guys, and there's 5 marks, we have to give reasons. Okay, so first thing we can work out is that this angle here is, okay, well, actually, let's do this first. This angle is 90 degrees and this angle is 90 degrees. So let's put both of these here. I'll say angle ABP and angle ACP are 90 degrees as AB and AC are tangents, and tangents meet the radius at 90 degrees. I don't have to write that down, but okay, let's write it. And tangents meet radius at 90 degrees. Okay, so we have those are 90. Next thing to note is this y here, there's only one angle that I can find using this y, and it's actually this one here, because this is double this. Now, guys, it's important, it's this one they have to both kind of be on the same side below. So this one below these two, well, the two radiuses, and this one below the two chords, right? So that is the angle at the circumference, that is the angle at the center. This is double that. So this has to equal 2y. So I'm going to say reflex angle BPC. You have to say the reflex angle, but reflex BPC equals 2y as angle at the center. Angle at center is twice angle at circumference. Now, this is an annoying question, guys, because you have to write all the reasons, but look, you have to do it, whatever. So if that's 2y, this guy is here 360 minus 2y. So now I'm going to say obtuse angle BPC equals, well, it equals 360 minus 2y as angles around a point, add to 360. Okay, then once we have this and this, we can say, okay, well, these four have to add up to 360. So I can then say that 360 minus 2y plus 90 plus 90 plus x equals 360. This is the angle in this big quadrilateral, or the angles, the four angles in this quadrilateral add to 360, because angles in a quadrilateral add to 360. I'm just going to write that too, as angles in a quadrilateral add to 360. Now, once we've got to that point, we just need to rearrange this to get this here. So I can say 360 plus 90 plus 90. Well, what I can actually do is subtract 360 from both sides. So now I have minus 2y plus 180 plus x equals 0. I'm going to get y, so let's bring the y over here. I'll say 2y equals 180 plus x, and then y is equal to, this divided by 2 is 90, and this divided by 2 is x over 2, which is what he wanted, hence QED. Okay, long annoying question, guys, but there you go. 16. Solve the simultaneous equations. Do not use trial and improvement. You must show your working. Okay, so we are going to okay, best way to do this, I think, guys, is we will make, I'm going to say therefore, let's make x the subject here. X is equal to 19 over 4 plus y. Okay, now once I have that, I'm going to sub this into here. So instead of x, I'm doing 19 over 4 plus y. That's my x. And instead of, well, sorry, and then it's just y. So this times y, that's my x times y equals negative 3. Multiply out, I get 19 over 4y plus y squared equals negative 3. Multiply across by 4, 19y plus 4y squared equals minus 12. 4y squared plus 19y, add the 12 over here, plus 12 equals 0. Okay, now we need to factorize. Let's do our a times c method, guys. A times c, 4 times 12 is 48. Factors of 48, that will add to give me 19. Probably guys, 16 and 3. Definitely 16 and 3. Okay, good. So now I have 4y squared plus 16y plus 3y plus 12 equals 0. Factorize the first two, 4y, y plus 4, plus 3, y plus 4 equals 0. 4y plus 3 times y plus 4 equals 0. Okay, once I have that, I can find my y. So 4y plus 3 equals 0, or y plus 4 equals 0. 4y is negative 3, y is negative 3 over 4. Or here, y is equal to negative 4. Now we know from this, guys, x is 19 over 4 plus y. Let's just write this here. X is 19 over 4 plus y. So here, x is 19 over 4 minus 4. And here, x is 19 over 4 minus 3/4. Okay, so this one is 19 over 4 minus 3 over 4, which is 16 over 4, which is 4. So x is 4. And here, this is 19 over 4 minus 16 over 4, which is 3 over 4. So my answers are, what's it actually asking, guys? Solve them. So I need my x and y. So I have x equals, let's write them both clearly, guys. So I have my x equals 4 and y equals negative 3 over 4. X equals 4, y equals negative 3 over 4. Or x equals 3 over 4 and y equals negative 4, like that. Okay, and if you just sub them back in here, guys, you'll see that that works. Does 4 times negative 3 over 4 equal negative 3? Yes. And does negative 4 times 3 over 4 equal negative 3? Also, yes. And you can sub it into the other one if you want. Okay, question 17. Point P lies on the circle. OP has an angle of 60. Show that the coordinates of P are 2 and root 3. Okay, so first and foremost, the radius is equal to the square root of 16, which is 4. That is always r squared. So this is 4. Okay, coordinates are then, they are the y, and they are, let's just draw it in green, the x. So I basically need to find x and I need to find y. So I can say sine 60 is y over 4. Sine 60, I know, guys, is, we need to know this, sine 60 is root 3. Sine of 60 is root 3 over 2. So root 3 over 2 is y over 4. Multiply across, y is equal to 4 root 3 over 2, which is 2 root 3. Similarly, for the x, I'm going to say cos of 60 equals x over 4, adjacent over hypotenuse. Cos of 60 is 1 over 2, so 1 over 2 equals x over 4. Cross multiply, x is 4 over 2, x is equal to 2. Okay, that is 17a. 17b, work out the equation of the tangent to the circle at P. Write your answer at this, in this form. Okay, so tangent to the circle at P. I have, guys, okay, can I do it up here, please, guys? 17b. So the tangent to this circle is going to be something like that, the equation of this line. So to get the equation of a line, I need a point, guys, which I have. It's 2 root 3, and I need a gradient. Now the gradient, let's do the gradient of OP. The gradient of OP is actually just going to be y over x, which is this over this. So it's rise over run, so y over x. So that's 2 root 3 over 2, which is just root 3. So the gradient of the tangent, let's call it m tangent, t for tangent, is going to be negative 1 over root 3. Okay, so now I've got my point and I've got my tangent. Let's actually complete the question down here, guys. My point is 2 comma 2 root 3, and my gradient is minus 1 over root 3. Okay, and then he says find the equation of the tangent. I'm going to use, guys, this formula, y minus y1 equals m into x minus x1, and then I'm going to say y minus 2 root 3 equals m minus 1 over root 3 into x minus 2. Multiply across by root 3, I get root 3y minus root 3 times root 3 is 3, and 2 times 3 is 6, so that's 6, equals, multiply the right by the root 3, which will make this disappear, minus 1 times x is minus x, and minus 1 times minus 2 is plus 2. He wants it in this form, so I'll bring the x over here, x, I'll do plus root 3y, that's my ay, and then this equals 2 plus 6, which is 8. Okay, so this is x plus root 3y equals 8. Okay, that is question 17, guys. Question 18. In triangle RST, RS to ST, so RS, the ratio of RS to ST is 1 to 4, RS to ST. So I'm going to put 1 to 4 here, guys, although just note these are not lengths, but it's that ratio. Okay, so we want the sine of theta. Now this is 135 degrees. Okay, we actually do know the sine of 135 degrees, or at least we can figure it out. Let's use the sine rule. So I can say sine of theta over 1 is equal to sine of 135 over 4. Now that works, guys, even though these are not lengths, it still works because it's all about like sine, cos, and tan are all just about the ratios of triangles, so that still works. Sine of theta over 1 is equal to sine 135 over 4. Now, what is the sine of 135? Well, sine 135 equals the sine of 45, if you remember from the cast diagram. If you do that, guys, cast diagram, sine of 45 is here, sine of 135 is here. They have the same y coordinate. So sine 135 equals sine 45. So sine 45 is 1 over root 2, or root 2 over 2. Let's just go with 1 over root 2. Sine 45 is 1 over root 2, so sine theta is 1 over root 2 over 4, which is actually equal to 1 over 4 root 2. Okay, and that's correct. You can, guys, rationalize the denominator if you want. So this equals, if I multiply by root 2 over root 2, I get root 2 on the top, and then root 2 times root 2 is 2, 2 times 4 is 8, so it's root 2 over 8. Okay, that's question 18. 19. Write this in this form. Basically, guys, complete the square. Okay, so we have to first take out the 6. So it's 6 brackets x squared minus 4x, because I've taken out the 6, and then close the bracket, and the plus 17, just leave it over here, not doing any harm to anyone. Okay, so then I complete the square inside this bracket. Complete the square means we half the 4, so that becomes 2. I then square that. I subtract this squared, always subtract, no matter whether this is plus or minus, you always subtract it, because it's like the extra bit when you expand this out. So I need to subtract 4. I then close the square bracket, and then the plus 17 again, not doing any harm out there. Then this guy, we just multiply across. I get 6, or multiply out, 6 times x minus 2 squared. 6 times minus 4 is minus 24 plus 17 still here. And then finally, I'll add the 17. So 6 times x minus 2 squared minus 24 plus 17 is minus 7. And that's it. Done. Okay. Question 20. The curve has 3 stationary points. Work out the coordinates of the 3 stationary points and determine their nature. You must show they're working. Okay, so their nature, guys, this will probably be, well, it will be the second derivative. Okay, so stationary points, first derivative, dy dx equals 0. Their nature, as in if it's a max or a min, is the second derivative, d2y dx squared. Okay, first, let's get dy dx. dy dx is equal to 4x cubed multiplied by the power and subtract 1 from the power minus 36x. Okay, set this equal to 0. 4x cubed minus 36x equals 0. Okay, let's take out 4x, guys. I'm going to take out 4x here, common factors, and then this is x squared minus 9 equals 0. This, nicely, is a difference of 2 squares. I can say 4x. This is x plus 3, x minus 3 equals 0. So I have 3 solutions. X equals 0, comma, x equals negative 3, comma, x equals positive 3. Those are my 3 x's. I need, however, 3 y's to go with them. So if x is 0, y is equal to 0 minus 0, so that's just 0, 0. If x is minus 3, y is equal to, okay guys, I'm going to have to do this over here. Minus x equals minus 3. Okay, y is equal to minus 3 to the power of 4 minus 18 times minus 3 squared. This, in my head, is not going to be nice. This is going to be minus 3 to the power of 4 is 81, is positive. This is 81, and this is going to be minus 9 times 18 is actually 9 times 9. 9 times 9 times 2, which is 162, which actually gives me negative 81. And when x is positive 3, so this one is y is equal to negative 81. And when x is positive 3, y is equal to 3 to the power of 4 minus 18 times 3 squared. It's actually exactly the same thing, which is minus 81. So my 3 points are 0, 0, minus 381, and minus 3 minus 81, and 3 minus 81. Okay, those are the 3 points. But now I need to determine their nature. So let's get the second derivative. Cannot believe, guys, how little space again, but there you go. d2y dx squared. The second derivative is the derivative of this. So multiply by the power, 3 times 4 is 12, 12x squared, and minus 36x. Okay, for the first one, when x equals 0, sorry guys, I just realized I made a mistake. That is minus 36, not 36x. So when x is 0, d2y dx squared, the second derivative, is sub in 0. It's negative. It's less than 0. When x is negative 3, d2y dx squared, sub in negative 3 in here, this will become 3 times 3 is 9. 9 times 12 is, well, it's certainly bigger than this. So this is greater than 0. And then finally at x equals 3, d2y dx squared, same reason, is greater than 0. Okay, so that means the The ones where d2y dx squared is greater than 0 is a min, and if it's less than 0, it's a max. So let's go with this one first. 0, 0. This is second derivative is less than 0, so it's a max. This guy, -3, -81. This is a min because the second derivative is greater than 0. And finally, this one, 3 minus 81, is a min because, again, the second derivative is greater than 0. Okay, nearly there, guys. Question 21. Show that this is equivalent to this. Okay, so we are going to just take this thing on the left and break it down until it becomes this thing on the right. Okay, how we're going to do that? Let's find out. So I'm going to start, I think, by I think we can divide. Let's divide everything. So this divided by this is 4. Well, sorry, let's write this thing on the left first. So 4 cos squared x plus 3 sine squared x minus 4 all over cos squared x. Okay, this is equal to, let me move this over here. This thing is equal to, this over this is 4. This over this is 3 tan squared x. So it's 4 plus 3 tan squared x, because sine over cos is tan, so sine squared over cos squared is tan squared. And then this is minus 4 over cos squared x. Okay, now I have this. Okay, so this is equal to, we've got 3 tan squared x, and I think I am going to go, okay, I think I know what I'm going to do. I'm going to do 4, I'm going to separate these two here, guys. Yes, I'm going to do, actually I realized what I could have done differently at the start, but let's just say we did this. I'm going to say this 4 minus, let me just show you like this, 4 minus 4 over cos squared x plus 3 tan squared x. Just literally swap those two around because I'm going to combine these two. So this is going to be 4 cos squared x minus 4 over cos squared x. I've joined these two together with a common denominator with this 4. Now, this is why I said I could have at the very start just joined them together, but this is fine. And then this is plus 3 tan squared x at the side. Okay, now I'm thinking that I need a tan squared x. So how do I get tan? I get tan with sine over cos. And then I look at this and I go, well, this is equal to 4 into, well, if I take out the minus 4, guys, that's even better. If I take out minus 4, this is going to be minus cos squared x plus 1 over cos squared x. And then over here, it's plus 3 tan squared x. Now, why did I want that? Why did I take out the minus 4? Because 1 minus cos squared x, and that's something, guys, you should be very familiar with. Sine squared x plus cos squared x equals 1. This is given in the formula sheet. So that means sine squared x is equal to 1 minus cos squared x. So this is sine squared x. So I'm left with minus 4 sine squared x over cos squared x, which is going to be my tan squared x, plus 3 tan squared x. This is tan squared x, so it's now minus 4 tan squared x plus 3 tan squared x, which equals minus tan, like minus 1 tan squared x, if you like. Okay, and thankfully, guys, that says end of questions. So that's paper 1. I will do paper 2, guys, hopefully soon.